All right, arc cosine is square root of 3 over 2. So remember when you're got the arc, you're looking for theta, right? Now for arc cosine, your input has to be between what two numbers? Negative 1 to 1. And your output's going to be between what two numbers?
Pi 1/2.
0 to pi. It's cosine this time, okay? It's arc cosine. So it's the square root of 3 over 2. Is that between negative 1 and 1? Well, put it in your calculator and hit enter, and it's going to tell you yes, it is, okay? All right, so we can do this. So remember, this means then that cosine of theta is equal to the square root of 3 over 2. Well, what is cosine in terms of x, y, and r?
X over R.
But this tells me r is 2. And we can't have that on our unit circle. And that's the only way we know to find exact values. So then put that fraction over 1. So now it's x over r still. But r is 1. Do we have x as the square root of 3 over 2 on our unit circle?
Yes.
So where? All right, well, let's think about it like this. Yeah, where is my angle got to come from? You told me my output there has to be between 0 and pi, correct? So if I'm looking at it between 0 and pi, I'm looking, see, here's 0, and I'm going to go to pi that's over here. So I'm looking for quadrants 1 or 2, correct? So look in quadrant 1 and 2 and tell me where is x equal to the positive square root of 3 over 2? At 30 degrees, which is pi over 6. All right, so let's try B. The inverse cosine of 0.5. We'll check, is 0.5, is your input within the domain of arc cosine?
Yes.
It's between negative 1 and 1, so we can take this. So remember, we're looking for theta. Theta's got to be between 0 and pi, doesn't it?
Yes.
So we're looking for quadrant 1 or quadrant 2 angles still. So when I rewrite this, I've got cosine of theta is equal to, I'm going to rewrite 0.5. That's the same thing as 1/2, isn't it? And we know cosine is x over r, but if I just do x on top, r on bottom, that means r is 2. So I'm going to put that over 1. So I'm looking for where x is positive 1/2, and remember we're in quadrant 1 and quadrant 2. So theta is pi over 3. All right, so C is talking about arc tangent. Now remember, arc tangent, your input is negative infinity to infinity, and your output is negative pi over 2 to pi over 2, but we can't include them. So what quadrants are we looking at if it's got to be between negative pi over 2 and pi over 2? So we're looking, yes, just like for the arc sine, or the inverse sine, we're looking at quadrants 1 and 4. All right, so is my input okay? Is it in my domain of the arc tangent?
Oh, yes.
Yes, it's from negative infinity to infinity. So we're looking for tangent of what angle gives me 1. Well, if I write that as a fraction, that's 1 over 1. But remember, tangent's what in terms of x, y, and r?
1 over x.
So I don't have anywhere, though, in quadrant 1 and 4 where y is 1 and x is 1. But what do I know about x and y? They're equal, aren't they? So it may not be a 1 and a 1. It may be a 3 and a 3, or a 7 and a 7, or a square root of 2 over 2 and a square root of 2 over 2.
I'm liking that one.
And so x and y are equal at pi over 4. Now, what if it had been a negative 1? That means one of them would be positive and the other one would be negative, so it would have been in quadrant 4, okay? All right, so for D, we're looking for the inverse tangent of square root of 3 over 3. Now, that's in my domain of the inverse, right? Because it's from negative infinity to infinity. So we're looking for theta. Remember, theta is going to have to come out of quadrant 1 or 4 because it's between negative pi over 2 and pi over 2. So I want to know tangent of what angle gives me the square root of 3 over 3. Well, tangent, you said, is y over x. But I don't have anything that has y is the square root of 3 while x is 3. If I tried to put this over 1, I still don't have anything where y is the square root of 3 over 3 and x is 1. But there's got to be a way to work this because square root of 3 over 3 is in the domain of my inverse tangent. So, tangent's a weird one. Just like earlier when we did C, remember we just said, well, that meant x and y had to be equal. So I need an x and a y that when I divide them, I get the square root of 3 over 3. So first thing then, am I going to be in quadrant 1 or 4 here? Quadrant 1, why?
Because it's both positive.
Because tangent's positive in quadrant 1, and remember tangent's negative in quadrant 4, and I have a positive square root of 3 over 3. So we know we're looking at an angle in quadrant 1. So look at your ordered pairs in quadrant 1. 2 of them have a square root of 3 in it. You have, pi over 3, which has the ordered pair of
1 over 2 is negative.
No, 1/2 and square root of 3 over 2. And then you have pi over 6, which has an ordered pair of square root of 3 over 2 and 1/2, right? Well, one of these, when I take y and I divide it by x, like you told me tangent is, I'm going to get the square root of 3 over 3. So how do I know which one?
You just do it.
Yeah, just pick one and try it. So which one do y'all want to try? Pi over 3? Alright, so if I take that one, I'm going to take y over x, which is the square root of 3 over 2 over 1/2. Keep it, change it, flip it. And we get the square root of 3. Is that what we wanted? No. So, unless I made a mistake, that's not the one. I'm probably looking at pi over 6, but I'm going to make sure I want to use pi over 6. So try it. So I'm going to come up here and do this. So y over x. So 1/2 over the square root of 3 over 2. Keep it, change it, flip it. Can't have the radical on bottom, so multiply the top and bottom by it. And we get square root of 3 over 3, which is what we wanted, right? So by doing that, we found our theta was equal to what? Pi over 6.
Wow, they're all pi over 6.
Just a coincidence.